All right, welcome back. This is section 3 from chapter 6, performing function operations and compositions. First of all, we're talking about power functions. Power functions are a function of the form y equals ax to the b power. That's y equals ax to the power of b. And basically some information, a has to be a real number and b is a rational number, meaning you have to have a nice number up here, no square roots, no imaginary numbers. A has to be real. A composition now is the composition of a function g with a function f. It's basically, it looks like this. When you put, it's a function of a function. You're putting two functions together at the same time. It's written like this, f of g of x. So you say f of g of x. Okay. And before we start here, I want to talk to you about domain and range problems. You're going to be asked, what is the domain of an equation? And there are two big problems. Two big problems when dealing with domain. First of all, you can never divide by 0. Okay? So never divide by 0. What we're dealing with there then is the fact that if you have something like, let's look over here, if you have something like 1 over x, you cannot divide by 0. So what you would write is you would say all real numbers but 0. You could say that x does not equal 0. And that's actually the best way of doing this. If you look at 1 over x and you see there is a variable in the denominator, then say that that denominator cannot equal 0. And then you can solve. Now the reason it's nice to do it that way is because then you can solve. You know, a lot of times we solve equations and you say, well, what makes that equal to 0? So if you have something like 1 over x plus 2, you see that there is a variable in the denominator. So say that that denominator cannot equal 0. That denominator cannot equal 0, so subtract 2 from both sides, and you then say that x cannot equal negative 2. Doing it this way will really speed things up for you when it comes to domain problems. The other problem with domain is you can never have an even root of a negative number. All right. So what this one's dealing with is you could not have, when you're dealing with, anytime you see a square root, automatically know that you cannot have a negative number in there. So if you looked at the square root of x, what's inside the radical has to be greater than or equal to 0. That means if you have x plus 2, that has to be greater than or equal to 0. If you have the square root of x squared plus 4, that has to be greater than or equal to 0. All right, those are the types of things ways to set this up, and we'll talk about that in the next few slides. All right, so operations of functions. Let f and g be two functions. A new function h can be defined by performing the basic operations. So addition, you're doing f of x plus g of x. Back in chapter 5, you had to add polynomials. That's what you're doing here. F of x is 3x. G of x is h plus 3. So f of x is 3x. G of x is x plus 3. That's what's written right here. Now you combine like terms. So 3x plus x gives you 4x. Your domain, your new function here is 4x plus 3. If it asks you for the domain and range, are we dividing by x here? Do we have an even root somewhere? If the answer is no to those, if there are no problems, you just say all, you just write that, all reals. Here, subtraction. It's the same, 3x minus x plus 3. The thing you have to be careful about is that this negative works on both of the things in the parentheses. So really, this is rewritten as 3x minus x minus 3. 3x minus x, that's 2x, and then just minus 3. Are there any problems with the domain? So then it's all reals. Multiplication now is, again, go back to chapter 5 when you're dealing with multiplying polynomials. F of x is 3x. Then you're multiplying it by g of x, which is x plus 3. And you have to remember how to distribute. Take the 3x times x. Well, the 3 times 1 is 3. X times x is x squared. 3x times 3, that's 3 times 3 is 9. X, there's no x, so just 9x. Look at the domain. Are you dividing by a variable? Are you doing a square root or an even root? The answer is no to both of those, so you would say all reals. Division becomes a little bit tougher. This time f of x is x. G of x is x minus 3. You can't simplify this whatsoever, so the answer is just 3x over x minus 3. Now, are there any square roots? The answer is no. Are you dividing by 0? Well, you have a variable down here, and like I said in the previous, the first slide, I said what you'll want to do is say that this is not equal, cannot equal 0. So when you add 3 to both sides, you get that the domain is x cannot equal 3. That's the only problem that would be in there. So the domains of h consists of the x values that are in the domains of both f and g. Additionally, the domain of the quotient does not include x values for which g of x is equal to 0. So basically, whatever makes g of x not equal, g of x equal to 0 is the domain. All right, let's take a look at this example here. We're doing f of x plus g of x. So here's f of x. You're adding it to g of x. And here it's written for you, f of x, adding it to g of x. Now, hopefully you remember from section 2, chapter 6, section 2, that x to the 1/2, x to the 1/2, they are like terms. So all you're looking at is the 3 plus the negative 5. Well, 3 plus negative 5 is negative 2. And then your like term x to the 1/2 power. So that's part A. Look at part C is asking you to find the domain and range. So you're looking for part A. You have negative 2 x to the 1/2. Now all of you see you're not dividing by 0. But none of you, but you all also should see that you have an x to the 1/2, which is really negative 2 square root of x. Uh-oh, square root of x. If you go back and look, if you have the square root of x, you just simply say let it greater than or equal to 0. . Okay, make it x is greater than or equal to 0. And that's pretty much it. The domain for this would be all non-negative real numbers, or x is greater than or equal to 0. Those are all the non-negative numbers. All right, take a look at B, subtraction. Here's f of x again. Here's g of x. We are subtracting. In example A, it was plus the negative, so we subtracted. Here, it's minus a negative. A minus means plus. So 3 plus 5 is 8x to the 1/2. All right, 8x to the 1/2. That is 8 to the square root of x. Can you have the square root of a negative number? No. So you write x is greater than or equal to 0, and that can be how you write the domain. Another example. Now we're multiplying. F of x is 7x. G of x is x to the 1/6. So when we do f of x times g of x, here, this is f of x, this is g of x, we are multiplying. What do you do? Here's the exponents of 1. What do you do when you have the same base, x and x times x? What do you do to those exponents? This goes back to the property of exponents. Well, you add them. Plus 1/6. So 1 is really 6 over 6. 6 over 6 plus 1 over 6 becomes x to the 7/6. And 7 times a coefficient of 1 gives you 7. So your answer, this is the product of f of x with g of x. Please note that x to the 7/6 is actually the 6th root, or an even root, of x to the 7th. Right, an even root. Go back again to here, to the problems. Never have an even root of a negative number. So if you have an even root, this stuff inside has to be greater than or equal to 0. So if it asks for the domain, domain of f consists of real numbers, and domain of g consists of so then x is greater than or equal to 0, so the domain of f times g consists of x is greater than or equal to 0. Basically, look at the original, look at what you start with, look at what you come up with. If there are ever any problems, that's the domain. All right, now division. So f of x is 7x. G of x, x to the 1/6. All right. So that's pretty much it. 7x. Oh, I guess not. Hold on. X to the 1/6. So what do we do with those exponents? Same base. Same base. Subtract the exponents. So 7x, 1 minus 1/6. That becomes 7x to the 5/6. All right. So 7x to the 5/6. All right, let me write that down here. 7x to the 5/6. So you see a 5/6, that means the 6th root of x to the 5th. And we go back to the problems from before. Never have an even root of a negative number. So this is an even root, has to be greater than or equal to 0. So the domain is that x is greater than or equal to 0. Those are the positive real numbers. All right, let's go to next slide. All right, so checkpoint. This is checkpoint number 1 on your note-taking guides. We have to do f plus g, f minus g, f times g, and f divided by g, and come up with the domains. So let's start with f plus g. That means you take f of x, which is 5x to the 3 halves, and you're adding it to negative 2x to the 3 halves. Now you should be somewhat happy because look, x to the 3 halves, x to the 3 halves, they are like terms. So 5 plus negative 2 gives us 3x to the 3 halves. Now, domain issues here. Remember, x to the 3 halves is actually 3 square root of x cubed. You cannot have a negative, take the square root of a negative number. You just can't do it. So that means x cubed has to be greater than or equal to 0. So our domain is x greater than or equal to 0. Now, part B, f minus g. Now we're doing 5x to the 3 halves minus negative 2x to the 3 halves. So minus a minus is plus. So 5 plus 2, 7x to the 3 halves. And then if you think about the domain the exact same way, the domain is x is greater than or equal to 0. F times g. Now that we get into the properties of exponent a little bit more. 5x to the 3 halves times negative 2x to the 3 halves. All right, so we look at each piece. Look at the numbers separately. 5 times negative 2 is negative 10. Now you look at x to the 3 halves times x to the 3 halves. Well, you add the exponents. 3 halves plus 3 halves become 6 halves. 6 halves ends up just being negative 10x cubed. All right. So what you see here is you don't see a domain issue here. All right, but you will see it in this and this. All right. So for this one here, you still have to say that the domain is x is greater than or equal to 0. F divided by g, that means you've got 5x to the 3 halves divided by negative 2x to the 3 halves. X to the 3 halves divided by x to the 3 halves becomes 0, or I'm sorry, becomes 1. They cancel out. And you just end up with 5 halves. Now again, there should not be, there is not a domain issue with 5 halves, but there is for each of these. So that's why the domain here would be x is greater than or equal to 0. All right, so keep that in mind. Now let's take a look at some of the guided practice. All right, so looking at 6.3, the first guided practices for number 1 is to take f of x and subtract g of x. Now, f of x, the function for f of x is negative 2 to the 2x to the 2/3. G of x is 7x to the 2/3. Now, right away, look at these and see if there's any domain issues. X to the 2/3, x to the 2/3, that means, uh, that simply means the cube root. That's an odd root of x. If you have the odd root of x, there are no problems. So start off by doing, I think number one is plus. So we're going to do negative 2x to the 2/3 plus 7x to the 2/3. And since x to the 2/3 and x to the 2/3 are like terms, you add the coefficients. Negative 2 plus 3, or plus 7, gives you 5x to the 2/3. Have never been any domain problems with cubes, so you would just simply say all reals, just like that. All right, 2. 2 wants you to do the subtraction. F of x minus g of x. So, negative 2x to the 2/3 minus 7x to the 2/3. The variable and the exponents are the same, so you do it just like before. You combine the coefficients. Negative 2 combined with a negative 7 gives us a negative 9x to the 2/3. Domain says, what is the domain of them? Since it's a cube root, there are no problems with a odd root. So you simply write all reals. Okay, so that was number 3, was doing the domain. Number 4 tells us that f of x is 3x, and g of x is x to the 1/5. Again, an odd root. No division of 0, so there are no problems here yet. Number 4 says to find f times g. That's 3x times x to the 1/5. Well, remember, exponent here is assumed to be a 1. Same base, add the exponents. So x to the 1 plus 1/3. Multiply the coefficients. 3 times 1 is 3. So my final answer is 3x to the 4/3. And since you have an odd root, the domain is all real numbers. Number 5, division. F of x divided by g of x. All right, now so far there's no problem with domain and range. Let's do the division. So f of x is 3x, g of x is x to the 1/5. So when we do this, it's 3x to the 1 minus 1/5. Oh, whoops, that should be a 5. 4/5. 1 minus 1/5 gives us 3x to the 4/5. So there should not be any real problem with this. All right, guided practice are done. Let's take a look at what it means to be a composition. Composition means where you have f of g of x. You're basically taking one function and putting it into another function. Here, h of x is g of f of x. The domain of h is the set of all x values such that x is in the domain of f, and f of x is in the domain of g. So, all this is, if you had f of 2, if f of x was 2x plus 4, and I said that x was 2, you would simply input that number in. 4 plus 4 is 8. I could do the same thing. Let's say instead of 2, I wanted to input an A. Well, now any place there was an X, you put an A. So instead of 2 times 2, it's 2 times A, so it's 2A plus 4. You can substitute whatever you want. All right, that means for this example, right? Follow this example for the example. This example will be followed in example 5 of your textbook. F of g of x. Well, first of all, what is g of x? Don't try to do the whole problem at once. What is g of x? Well, let's look at the information up here. G of x is 3x plus 5. So instead of inputting a number or one nice variable, you're going to be inputting you're going to be inputting a bunch of information. So 3x plus 5. Well, every place, here's f of x. X is replaced with 3x plus 5. So this x is replaced with 3x plus 5. So 6, 3x plus 5, so negative 1. All you do is you replace the x's with what you're inputting right there. From here, negative exponent property says that you put 3x plus 5 in the denominator. All right. Now, all the way back at the beginning, when we talked about dividing by 0, you say that this cannot equal 0. So subtract 5. 3x cannot equal negative 5. You divide by 3. X cannot equal negative 5/3. All right. Let's do B and then we'll move on. B says to do g of f of x. So the first step you should do, what is f of x? G times f of x, 6x to the negative 1. So now looking at the g function, anytime there's an x right there, you put 6x to the negative 1. So 3. Oh, there's an x. 6x negative 1 minus plus 5. All right. Well, we've got some work to do right here. 3, distribute the 3. 3 times 6 is 18. X to the negative 1 plus 5. Well, this negative only is working on the x. So it should become 18 over x plus 5. And you're done. The domain, though, says that the denominator cannot equal 0. Cannot equal 0. So that means the domain is that x is all real numbers except x cannot equal 0. All right. Let's complete this checkpoint. Let's do A and B again. So for part A, we have to find f of g of x. So start by looking up what g of x is. G of x is 3x to the negative 1. So now when I look at the f function, any place there's an x, I put 3x to the negative 1. So f of 3x to the negative 1 equals 5. There's an x, so put 3x to the negative 1 minus 4. Well, 5 times 3x to the negative 1, that becomes 15x to the negative 1 minus 4. And since this, just the x, has a negative exponent, it becomes 15x to the first minus 4. So, what problem does this have? What problem do we have for domain here? Well, cannot divide by 0. So our domain, x, cannot equal 0. Take a look at B. G of f of x equals g, of course, and then you put what f of x is equal to, 5x minus 4. Well, the g function is 3x to the negative 1, so start with 3. It goes 3x, so the x becomes 5x minus 4. It's like you're substituting to the negative 1. All right, this is just like the example we just did, because this whole piece here has a negative exponent. So we flip it and put it in the other side of a fraction, 5x minus 4. And when it's asking for domain, you say that that denominator cannot equal 0. So if the denominator cannot equal 0, you add 4 to both sides. 5x equals 4. Divide by 5. And your domain is that x cannot equal 4/5. All right, so let us take a look at a couple of the guided practices here. Let's look at number 8. Oops. Number 8. Number 8 says that, oops, there we go, f of x is 3x minus 8, g of x 2x squared. All right, so I think number 8 says to do g of f of x. So put f of x in there. And now once you have f of x in there, you look at the g function and say to yourself, all right, the x became 3x minus 8, so this x becomes 3x minus 8. So 2 times 3x minus 8 squared. This is where you're going to run into trouble, because you're going to try to just square both sides, but that's not what being squared means. Squared means 2 times 3x minus 8 times 3x minus 8. So you have to FOIL. You have to FOIL everything here. So 2 times, this is multiplying polynomials. You did this back in chapter 5. 3x times 3x is 9x squared. 3x times negative 8 is negative 24. Negative 8 times 3, negative 24x. Negative 8 times negative 8, plus 64. So your new solution, your new function is 9x squared minus 48x plus 60. And were there any ever issues with the domain here? Were we dividing by 0 ever? No. Were we having the square root of a negative? No. So that means here you've got domain is all real numbers. All right, we're going to end with that. Here are your practice problems. Please look back over the video, look at the examples in your notes, look at the book. You know, there are plenty of examples here to help you figure out what you need to do to accomplish this section.